Alright, what's up, Year 13s? I am bored on a Friday afternoon, so I figured I'd take a look through a multiple choice section of a paper. I haven't looked at the mark scheme. I'm not sure how much of this I'm going to be able to remember from Unit 4, because it was a long time ago. So let's go through it, and I'll say what I think are the right answers. I want you to kind of watch it and see whether you agree with me. Feel free to check the mark scheme if you want to double check. And if you think I've made any mistakes, let me know. I'll try and justify everything I say. So question 1, a unit for magnetic flux. Well, this is really just something you've got to learn, and this is one I remember. This is the Weber, so A is the correct answer. So magnetic flux measured in Webers. Question 2, feel free to read it. I'm going to do the same. I'm not going to read it out to you. So I guess here really you've got M1v1 equals M2v2. It's an explosion, so the mass of the object moving to the left and the mass of the object moving to the right should be the same. Oh, sorry, not the mass. The mass times the velocity for both, the momentum for both. So I guess if M1v1 equals M2v2, then v1 over v2 must equal M2 over M1. Trying to do that in my head without a pen. I think I'm right there. I'm going to write it out anyway to make sure. M1 V1 equals M2 V2, so V1 over V2 is M2 over M1. Yeah, so I'm going to go with B as being the correct answer for that one. Question 3, which is a property of a uniform electric field? It doesn't change with time. No, it could change with time, I guess. Acts equally in all directions. No, that's a radial field. I think anyway, at least it could be. Only produce a force on moving charged particles. No, electric fields work on all charged particles, stationary or moving. It's got to be D, same strength at all points. Okay, question 4. Potential difference of 50 volts is applied between two identical parallel aluminium plates. Basically a capacitor, I guess. Well, kind of. It's two parallel plates, isn't it? The plates are separated by a distance of 10 mil. How could we double the electric field strength? Okay, so have a think about the equation that relates electric field strength, potential difference, and separation. So hopefully you got it. It's electric field strength equals V divided by D, voltage divided by distance. The way I remember that is that I know that one of the units for electric field strength is the volt per meter, and that lets me remember that. So if I want the electric field strength to double, then V over D, it needs to be double its original value. I'm just looking at them. It's going to be C, isn't it? Because the voltage doubles, but the distance remains constant. So therefore V divided by D will double as well. Okay. Which of the following is not a vector quantity? Electric field strength is, it has a direction. Magnetic flux density. Oh, I feel like that's a scalar. It's the density of the flux. I think that's a scalar. Momentum is definitely a vector. And potential difference, I'd have said that was a scalar off the top of my head as well, even though I know it can have a direction. I guess voltage has a direction. I'm going to say I think it's magnetic flux density. That doesn't have a direction. I'm pretty sure about that. So B is my answer. Okay, these two are mass m traveling towards each other with speed v. Which of the following statements must be true after the collision? It's got to be total momentum equals 2mv, right? So the momentum before is... Oh, no, the total momentum equals 0. Yeah, it's definitely B. They're going in opposite directions, aren't they? So the total momentum is 0. So yeah, B. 7. Cyclist travels along a straight horizontal road at a steady speed. Net force of 20 newtons is then applied for 6 seconds. Change in momentum of the cyclist. Okay. I know that the force is the change in momentum with the change in time. So the change in momentum is the force times the change in time. So that's 20 times 6, so 120 kilogram meter per second. So that gives me C as my correct answer. Question 8. Oh man, this is the one with the cos, isn't it? Conductor of length 50 mil carries a current 3 amps at 30 degrees to a magnetic field, magnetic flux density 0.4 T. What is the magnetic force acting on the conductor? Force equals, this is B I L cos theta. I seem to remember it didn't matter if you used cos or sine. Yeah, I don't know how it can be that it doesn't matter, but I'm sure it didn't. So what have you got? You've got 0.4 times 3 times the length, which is 50 times 10 to the minus 3 times cosine 30 cos 31. I don't remember. Man, I can't do this in my head. I didn't think about this. 0.12 times, is that right? No, 1.2 times 50 times 10 to the minus 3 times cos 30. Cos 30 is a half, I'm pretty sure about that. So that times 5. You can use a calculator for this, that's cool. 12, I'm going to make that 6, 60, 30 times 10 to the minus 3, which is what, 0.03? Yeah, I'm going to go with A as my correct answer. It's also made me think about the fact that magnetic flux density is the strength of the magnetic field, but B, I feel like B is definitely a vector, and that's making me think back about this question. Where was it? Up here. This one. I bet that is a vector. That's magnetic field. That is the magnetic field. Yeah, I remember. That is magnetic field. Therefore, potential difference is a scalar. You can see their classic example of how working through a paper can allow you to figure out an earlier question if you didn't know it. Okay, question 9. Both of these move into the same uniform magnetic field, which is perpendicular to the direction of motion. Beta particle is 15 times faster than the alpha particle. Ratio of the force. Okay, so what have we got? Magnetic fields, speeds, forces, and charged particles. So I'm going to use F equals BQV. We called it BeV occasionally, but that was only for the charge on an electron. So the force on the alpha particle, force on alpha, is going to be B, because I don't know what that is, times a charge of 2 times a velocity of 1. Yeah, that's cool with me. So that's 2B. That's the force. The force on a beta, again, BQV. B is constant, still B. This time Q is -1. And this time the velocity is 15. So this is minus 15B. I don't think we're going to be interested in that. The ratio of the force for 2 to 15 is 7.5, so it's B. And finally, the last question, question 10. The tubes of a linear accelerator get longer progressively down the length because the accelerating particles must spend the same time in each tube. Is that right? Why do they get longer? Let me not look at the answers. So the particles get faster. The frequency is changing at a constant rate. Yeah, that's right. So they must spend the same time in each tube is the correct answer, because the frequency is changing at a constant rate, and they're getting faster and faster. B is wrong. The frequency doesn't change. So it's C. I think I got 10 marks there, including the one that I changed my mind on. So take a look, see if you agree with me. Look at the mark scheme. This is, what is this? This is January 2013. You can see I have got the mark scheme open behind, but I haven't actually even looked at it. I can check it now. Shall I check it? Okay, let's do it. Okay, let's go. A, Weber, yeah, I said that. Next one, M2 over M1, yeah, I said that. Question 3, D, field same strength at all points, yeah, I said that. Question 4, C, yes, I got that right. 5 is D, yes, I changed my mind and I got it right. Nice. 6, yeah, B. 7, C, yeah, 120, yeah, I've got that written down next to me. Question 8, yeah, I said A, and I did that in my head as well, so props to you guys if you did that in your head. Question 9, I said 7.5, so yeah, that's B. And question 10, C, yeah, oh cool, 10 out of 10. So I remember most of Unit 4, even if it's not perfect. How did you guys do? Have a think if you agreed with me, and let me know. Now, I'm sat here on a Friday afternoon doing Unit 4 questions, and I haven't got an exam in a month. So think on. Have a good day, guys. Peace.